Professor, is this getting any strange feedback on this mic, or is it okay?
Not so. No strange feedback yet.
Okay, if it gets bad, I have another computer I can try. I don't know, this mic might be a little messed up.
Okay. Now this problem says to solve using substitution and/or elimination. No matter what, we never want fractions. So first thing I'll do is get rid of these fractions by multiplying everything by the LCM of all the denominators. So I'll multiply by 12. So that gives us x plus 12 times 1/3 is 4, so we got 4y equals 12 times 1/2, which is 6. Now, I'll use elimination. With elimination, if this is positive x, we want this to be negative x. So I'll multiply the second equation by negative 1. Negative 1 times x is negative x. Negative 1 times 4y is negative 4y. And negative 1 times 6 is negative 6. Now if I were to add these together, you get x minus x drops away, 4y minus 4y drops away, and 6 minus 6 drops away. Now when you come up with 0 is equal to 0, this is our dependent case. And what we'll do is we'll go back to our simplest equation. Here you got x plus 4y is equal to 6. And I want to solve this for x. So I'm going to take the 4y, move it over, and you get x is equal to 6 minus 4y. Now our answer is of the form x comma y. So that's our answer. We know what x is. It's 6 minus 4y, so we'll plug that in. And y just remains y. Now, just to really emphasize that this is can be anything, we're going to put a different variable here. And I think this book puts t's in there. So we'll replace the y with t. Now what this means is you can plug anything in for y. You can put 3 in there. Now if I were to put 3 in, for example, then I'd have to put 3 here. And I'd have 6 minus 4 times 3. So the x part is dependent upon whatever you put in for y. And that's why they call it a dependent system of equations. And that would be our answer. Does that make sense?
Yeah.
Okay. So number 16. We got 2x minus y plus z is equal to 1, or negative 1. And we got 4x plus 3y plus 5z is equal to positive 1. And 5y plus 3z is equal to 4. Let me double check all those. Okay, now our goal is we'd like to get some kind of x, some kind of y, some kind of z equal to some kind of number, and then some kind of y, some kind of z is equal to some kind of number, and then something before your z is equal to some kind of number. And you can have any numbers in here. But that's our goal, so it looks like a triangular form. Now, we need to get one of these down to where it just has a z alone. Because this one looks like, the second one here. And we could pick either one of these for the first one. Now, how we can get it down is we'll work at eliminate the x's on the first two equations. So let's take a look at those. So I got 2x minus y plus z is equal to negative 1. 4x plus 3y plus 5z is equal to positive 1. Now let's eliminate the x's by multiplying the first equation by negative 2.
Okay.
So then we'll get negative 4x plus 2y minus 2z is equal to positive 2. And 4x plus 3y plus 5z is equal to 1. Now if I add these, I see that the x's are eliminated. 2y plus 3y is 5y, negative 2z plus 5z is 3z, and 2 plus 1 is 3. So now we have this equation, and we have this one. So I want to pair those together. And then we'd want to work at eliminating the y. And then we'd be left with z is equal to something. And we'd have our third type. I'm sorry?
Yes.
So I'll multiply one of the equations by negative 1. So I got 5y plus 3z. Oh, I screwed that up, didn't I? Yeah, that should be a 3 there.
Oh, it's 3.
Yeah. Okay. So negative 1 times 5y is negative 5y. Negative 1 times 3z is negative 3z. And negative 1 times 3 gives us negative 3. (5y minus 5y drops away. 3z minus 3z drops away. And we've got 0 equals 4 minus 3, which is 1. Well, that's no good. We were hoping to get something like, 3z is equal to 6 or something like that.
Right.
But both of the variables got eliminated. Well, when you ask yourself when is 0 equal to 1, they're never equal to each other.
Right.
So this is our no solution or inconsistent case. So you don't have to go any further at that point. Once all your variables drop away and you get that, then it's automatically no solution. There's no answer to that, or it's inconsistent.
Does this mean that the lines will never intersect or something?
There's yeah, if you look at these right here, these planes, there's no place where there's an intersection where x, y, and z give you all three of these equations.
Okay. Okay.
You got that okay?
Yep, got it.
Okay, I'll go ahead and erase that.
Professor, this seems like looking at these equations, it kind of looks like matrices. Is this related at all to matrices?
You can use matrices to solve these easier than with this method.
Is there like a trick to that or something? Like it looks like a 3x3 matrix kind of.
You can. Do you want to see a Gaussian elimination using matrices after we go through your examples?
Yeah, that'd be great.
Okay.
So like, you say like the coefficients of the things or something, or?
Right.
I was looking at your videos the other day about Gaussian,
Gaussian.
Yeah, Gaussian elimination, but it's using the T83. Are we going to be able to use a T83 program for our final?
I'll double check on that and let you know.
Okay. Thank you. I mean, if we don't need to use a calculator, that's okay. But if we're going to be doing like logarithms and solving for stuff like that, then
right,
that'd be helpful. Unless we can just, unless they're obvious where they cancel out or something.
Mm-hmm. Now, number 30 says Skippy has a total of $10,000 split between two investments. One account earns 3% simple interest, and the other account earns 8% simple interest. For tax reasons, he can only earn $500 in interest the entire year. How much money should Skippy invest in each account to earn $500 in interest for the year? Well, they tell us there's going to be a total of $10,000. So I'm going to have x plus y is equal to 10,000. So that's our amount for
First.
Yeah, 3%. And then plus the other amount gives us our total. Now the second equation is based upon where you take your amount in the account times your percent. So the x we'll assume is the 3%. So we'll have 0.03x plus, and then the other one is 8%. So we'll have 0.08y. And the total interest we want to get from that is $500. So this will equal 500. So they're both accounts are working together to give you the total interest. Now, just like when we don't want fractions when we're solving these, we don't want decimals. So I'm going to multiply everything by 100 in the second equation. So you got x plus y is equal to 10,000. This, if I multiply it times 100, would give us 3x plus 8y equals 50,000. Now I'm going to use elimination. So I'm going to multiply the first equation by -3. So you got -3x minus 3y is equal to 10,000. And you got 3x.
10,000, right?
Yeah. The what? Oh, 30,000. Yeah. Okay. So then 3x plus 8y is equal to 50,000. Let me just double check my basic math since I'm... Okay. -3x plus 3x drops away. -3y plus 8y gives me 5y equals -30,000 plus 50,000 is 20,000. Then divide both sides by 5, and we get y is equal to 4,000.
Okay. So if it's 4,000 there, we know the other one has to be 6,000.
Right. And that'll give you your amounts.
Okay. Oh, that's neat.
Okay. Page 646.
Professor, can you show me one of these with a Gaussian elimination?
Yeah, let's do the other three problems. Just make sure I have time to show all those to you.
Okay. All right. Great.
I know last time we kind of ran out of time.
Yeah, I'm a little busy in the mornings. 646.
Some of these are not as easy.
Yeah.
Some aren't too bad, but let's see, number 5. Okay, x squared plus y squared equals 16. 1/9 y squared minus 1/16 x squared equals 1. Now with these, just like before, we x squared plus y squared, okay, 1/9 minus 1/16 x squared, okay. Just like before, we don't want fractions. Those are never easy to work with. So I'll multiply everything by the LCM of all my denominators in the second equation. So I'll multiply everything by 144. So we got x squared plus y squared is equal to 16. And we got 16y squared minus 9x squared equals 144. Now I want the x squared to be in the same column and the y squared to be in the same column, so I'm going to rearrange it. So I got negative 9x squared plus 16y squared equals 144. I'm going to use elimination, so I'm going to eliminate the x's. So I'll multiply the first equation by 9.
Mm.
And that gives us 9x squared plus 9y squared equals 144.
Oh, it's gonna be. Oh no, no, no. I
Is
thought
that
for a second it was gonna be a null inconsistent set, but awesome.
is that? I'm sorry, I
Oh,
didn't.
I almost thought it was being inconsistent because it's one. If it was negative 144, it'd be something equals 0, right?
Right, you'd get y is equal to 0 then.
Does that make it inconsistent, or does that just make it?
This makes it real easy.
Oh, okay.
Now, what would make it inconsistent is if I had come up with a negative 9y squared here, then these would both cancel away and leave me 0 over here equals some kind of number.
Okay.
And then that's where you could just stop, and I guess actually I'd make it pretty easy too. So that gives us 25y squared equals 288. Now I divide both sides by 25, so we got y squared is equal to 288 over 25, and y is equal to square root property. You drop your squared and you put a plus or minus square root around the other side. Now we don't want a fraction inside of a square root, so we split it up, put a square root around the numerator, around the top, and around the denominator, around the bottom. Now 288 is 2 times 144. 144 is 2 times 72. 2 times 36, 2 times 18, 2 times 9, 2, 4, 8, 16, 32 times 9. Okay, yeah, it does factor that way. All over, and square root of 25 is 5. So then we've got a pair of 2's here, we got a pair of 2's here, and a pair of 3's. So we'll have 12 out in front and 2 left inside. And we get y is equal to plus minus 12 square root of 2 over 5. Now we have to find our x value now. So we're going to continue. We're going to take that value. We're going to plug it into one of our equations. I'll plug it into x squared plus y squared is equal to 16. Now we'll plug that in for the y, and we're going to have plus or minus 12 square root of 2 over 5 squared equals 16. Now I'm putting a plus or minus there. Normally you just put one of them in there. You wouldn't put both of them. But I wanted to demonstrate what happens when you square something. Whether it's positive or negative, and you square it, it comes out positive, doesn't it?
Right.
So it doesn't matter which one you put in. It's going to give you the same x values.
Okay.
Okay, so then that's basically disappears anyway. 12 squared is 144. Square root of 2 squared is 2. And 5 squared is 25. Equals 16. So then we got x squared plus 288 over 25 equals 16. Take the 288 over 25 to the right side, and we got 16 minus 288 over 25. Then we want to get a common denominator. So we're going to have 25 as our common denominator. I'm thinking 400, but
400, 800, 400. Yeah.
Is it 400?
Let me grab my calculator.
It should be.
Okay, yeah. Sounds right.
Yeah. Because if there was just 4 here, then it would be 100 over 25. So, okay, and then that gives us 112. I better get my calculator.
I get it. Let's see. 400 minus 288. Yep, that's right. 112.
Okay. So then we'll drop our squared, put a plus or minus square root around the other side. But again, we can't have a fraction of a square root, so we'll split it up, put a square root around the top, square root around the bottom. Now 112 is 2 times,
Two.
I'm not doing very good with my basic math today. 56?
Yeah.
And then that's 2 times 28, 2 times 14, 2 times 7. 2, 4, 8, 16 times 7. Okay. Over 5. So then we got a pair of 2's here, a pair of 2's here, so that gives us 4 square root of 7 over 5. Assuming I didn't make a basic math error.
Sure.
Okay. So then we got plus or minus 4 square root of 7 over 5, and then for our y value, we have plus or minus 12 square root of 2 over 5. Now it doesn't always work out that way, where you can put them into one point form like that. Sometimes you have to list them separately. It worked out that way here because what I pointed out up here, when you got the plus or minus, when you square it, it gives you the same 2x or same 2 x values.
Yeah. So if there was a different value, if you had to like factor it out or something, and you get x equals 5 and x equals 2, something like that, then you would be able to put it into point form.
If you got two different values when you solved it, like if I didn't have the squared here, this was x squared plus y equals 16, then I would actually want to do them separate because you'd come up with 2 different answers.
Okay.
Oh, potentially. Let's see, that was number 5. Okay. So let's look at 15. Now they're saying solve these, and then they say use a graph to help you avoid any potential extraneous solutions. So they're telling you that you could potentially have some issues with these. So we got x squared plus y squared is equal to 25. And we got 4x squared minus 9y equals 0, and 3y squared minus 16x is equal to 0. Now some of these may have potential problems for other reasons, but what's a potential problem here is if we're solving a system of nonlinear equations in 2 variables, technically all you need is 2 equations. Now it could be possible that if one is so trivial you might need a third one to help you in the solution, but 2 is all you really need. So we're going to first focus on these 2 here. So I got x squared plus y squared equals 25. And I got 4x squared minus 9y is equal to 0. Now I'm going to multiply the first equation by negative 4. So I got negative 4x squared minus 4y squared equals negative 100. And then I got 4x squared minus 9y equals 0. So now if I add these, negative 4x squared plus 4x squared drops away, and this just comes down, so we got negative 4y squared minus 9y is equal to negative 100. Now if for some reason we are left with some kind of x in here, then I might have to use the other equation to work at eliminating. But since everything's in the same variable now, y, then we can work with this. So I'm going to take the negative 4y squared and negative 9y to the right side. So that gives us a positive 4y squared plus 9y minus 100. And we want to factor that. And let me double check that. 4y squared, negative 16y plus 25y gives us 9y. 25 times negative 4 is negative 100. Okay, factors that way. Then I'll set each one of those equal to 0. So we got 4y plus 25 equal to 0. And we got y minus 4 equals 0. So we got 4y is equal to negative 25. Or y is equal to negative 25 fourths. And on this one, we got y is equal to 4. Now we want to take those values and we want to plug it in to one of the equations. Usually the one that's best is the one with the smallest powers. Like the 4x squared minus 9y squared equals 0. So if we plug in negative 25 fourths, we're going to have 4x squared minus 9 times negative 25 over 4 equals 0. So we got 4y squared, or 4x squared, plus 225? 4. But when I solve this, notice what's going to happen. We get a negative value over here. So once I go through and do the get rid of the squared and put a plus or minus square root on the other side,
Doesn't work.
doesn't work. So we don't have to go any further on that once we spot that. So let's plug 4 in. So I got 4x squared minus 9 times 4 equals 0. So we got 4x squared minus 36 equal to 0. 4x squared is equal to 36. X squared is equal to 9. Or drop our squared and square root property, put a plus or minus square root on the other side. And we get x is equal to plus or minus 3. And that's all based upon y is equal to 4. Which means our two potential answers are 3, 4, and negative 3, 4.
Okay.
Now, we're going to want to check this. Obviously, it works in the 4x squared minus 9y, because we just, that's where we got it from. But since we got 3 equations, we want to make sure it's valid in all 3, since we got more than we need. I'd almost be tempted to say that since x squared plus y squared is equal to 25, I think that was one of them.
Yeah, x squared plus y squared is 20.
Yeah, I'd almost be tempted to say since that was part of the way we derived these answers that they're okay. But just to be on the safe side. If I put 3 in here, 3 squared plus 4 squared, we're wondering if that gives us 25. And it does. So that checks. Now, even if I put negative 3 in there, negative 3 squared is the same as positive 3 squared.
Right.
So that checks. But let's check the other equation. The 3y squared minus 16x equals 0. So we'll start with our first point. Plug this in for x, plug that in for y. So I got 3 times 4 squared minus 16 times 3. And we're wondering if that gives us 0. That's 48 minus 48. So that one works. So that one is one of our answers. Now if we plug in the other one. So we'll plug in the 4 for the y. Minus 16 times negative 3. And we're wondering if that's equal to 0. 4 squared is 16 times 3 is 48 plus 48. That doesn't give you 0, does it?
No, it does not.
So that one disappears. So your only answer is 3, 4.
Okay.
You always have to be careful when they give you 3 equations and you only have 2 variables. Technically, you don't need those unless, like I say, it's designed such that you have to get it to eliminate another variable.
Okay.
Or another term, I should say. Let's see, that was 15. When you send these to me, I kind of glance at them and make sure there isn't some surprise that I'm not ready for. And number 16 was one of them. It took me a little bit. I worked it wrong to begin with. Sometimes in math you have to take some wrong paths before you can come up with the correct answer. Okay, now this talks about the law of uninhibited growth. And if I remember right, that was the total number is equal to the initial number times e to the kt. Okay, so they tell us after 10 minutes there are 10,000 bacteria. So 10,000 would be your number. So they're giving us 10,000 equals n naught e to the 10 minutes. So I put 10 in for the t, and I got 10k. Now our second one says 5 minutes later there are 14,000 bacteria. So we'll have 14,000 is equal to n naught e to the
14k. Or 5.
15?
Oh, 15k.
Yeah. So that'd be 15k. Now what I did initially is I solved both of these for n naught, and then I used logs, and because I wanted to eliminate the e, and I came up with some bizarre answers. I'm not quite sure why I did. I may have just made a basic math error. It seems like logic-wise it should have worked. But then after I worked it the wrong way, and I looked at it again, it's like, oh, wait a minute, I'm working this too hard. It's much easier than that.
Multiply by -1 or something and eliminate?
Actually, I'll do substitution.
Oh, substitution. Okay.
Yeah, so this one I'll solve for n naught. So I'll divide both sides by e to the 10k. And then we're going to substitute that into the other equation. So you got 14,000 is equal to 10,000 over e to the 10k times e to the 15k. So we got 14,000 is equal to 10,000 e to the 15k over e to the 10k. Now when you got e to a power over e to a power, you subtract the exponents. So 15k minus 10k will give us e to the 5k. And then I divide both sides by 10,000. Get this. Now some of those zeros are dropped away, so we got 14 over 10, which reduces to 7/5, is equal to e to the 5k. Now we need to solve for k, so we'll take natural log of both sides now. So I got natural log of 7/5 is equal to natural log of e to the 5k, which gives us natural log of 7/5 is equal to 5k. And then you divide both sides by 5, and you get k is equal to natural log of 7/5 divided by 5. Which means that we now know what k is, and then we can go back to this formula right here and find out what n naught is equal to. So we're going to plug that into this right here. So n naught is equal to 10,000 over E to the 10 times K, and K was equal to this. So we'll have natural log of 7/5 over 5. So n naught is equal to 10,000, and those cancel a little bit. So that gives us e to the 2 natural log of 7/5.
Yep.
Okay, so let's plug that in. So we got 10,000 divided by E, second ln, and then 2 natural log of 7/5. So approximately 5102.
Professor, could you do this? Also, could you look at the two equations and then just multiply one of them by -1 and cancel out like n naught? Like you do it through like you multiply the first equation by -1, then add the 2 to cancel out. And is that
In
possible?
theory.
See, if you had like negative n naught e to the 10k plus n naught e to the 15k, would that then be e to the 5k?
Well, we'll go back and take a look at it here in a second. I'll set up this last part, and then we'll go back and look at that.
Okay.
The last part just asks you when is it going to equal something. 50,000. So they're wanting to know when this is 50,000. N naught was 5102. E to the k, which is where's k?
ln
Okay.
7/5 over 5.
So over 5 the t. So here, to solve this, you divide both sides by 5102. Equals e to the natural log of 7/5 over 5 t. And take natural log of both sides. And then you'd have natural log of 50,000 over 5102 is equal to natural log of 7/5 over 5t. And then you would multiply both sides by 5 over natural log of 7/5, and that would give you your answer.
Okay.
Now back to your question. This is what I did originally. So I don't know where I went wrong. But I had this. And if these were exactly the same, then you could multiply by -1, like you say. But I could divide both sides by n naught. Or no, divide both sides by e to the power. So that gives us 10,000 e to the 10k is equal to n naught. And then 14,000 divided by e to the 15k is equal to n naught. And now if you were to use elimination, so you got 10,000 over e to the 10k is equal to n naught, and you multiply this by -1, you'd end up with negative 14,000 e to the 15k is equal to negative n naught.
Okay. Right.
So then those would cancel away. And here on this side you'd have 10,000 over e to the 10k minus 14,000 over e to the 15k is equal to 0. And at this point, what I did is I took that over and came up with this. And then since this is a proportion where you have a single fraction equals single fraction, you can cross multiply.
Right.
So you take 10,000 e to the 15k is equal to 14,000 e to the 10k. And then I got them both on the same side. And see, at this point, I kind of drew a blank.
Right.
So I wasn't quite sure how to solve that at that point. So that's when I backed up. And now that I think about it,
Can you, when you have that, when you have 10,000 e to 15k minus 14,000 e to 10k, can you use log properties like to make it like log m plus n or log m minus
right.
n?
That's what I did. Is I took natural log of both sides, like this. And then, like you indicate, this is multiplication, so it would become addition. So it'd have natural log of 10,000 plus natural log of e to the 15k equals natural log of 14,000 plus natural log of e to the 10k. And natural log and e cancels, so we'll have natural log of 10,000 plus 15k equals natural log of 14,000 plus 10k. I got all the k's on one side, so I'd end up with 5k here equals, and then I took this natural log of 10,000 over. Yeah, I'm getting the same value this time. Because I could rewrite that subtraction as division. And that gives us, those zeros cancel, and 14 over 10 gives us 7/5.
Yeah.
I have no clue what I did wrong the first time. I don't even know if I kept my attempt. So I thought, well, I'm way off. And I was way off on the answer. Maybe I just typed in the calculator wrong. But yeah, that should give you the same result.
Okay.
Yeah, I came up with, here it is. I came up with k is equal to 7.704. Which if I plug that in, natural log of 7 divided by 5 divided by 5. No? Huh. I just plugged in the calculator wrong, I guess. My math was sound, but I just can't use the calculator. Does that make sense on that problem?
Yeah, it makes sense.
Okay. Well, let me back up and show a Gaussian elimination.
Cool.
Do you have time?
Maybe it's like 5 minutes or so. I should probably get going.
Okay, well, I'll choose a real easy one then and show you the concept. So we got 3x plus 2y is equal to 7. And we got 4x minus y is equal to 2. Okay. Now we write down a matrix goes along with that. We drop the x's, y's, and keep the numbers in their signs, and the equals drop too. And so we end up with this right here. Using matrices, we want to end up with a matrix that looks like this. So we focus first on this pivot number. And we see we need to divide that by a 3 to get a 1 there. So take row 1 divided by 3 gives us our new row 1. So 3 divided by 3 is 1, 2 divided by 3 is 2/3, 7 divided by 3 is 7/3. Now after we get 1 in that spot, then we want to, we've got a 1 here now, we want to work at getting zeros below it. So you ask yourself, what do you multiply times 1 that you can then add to 4 that give you a 0 here?
-4.
-4. So we'll take -4 times row 1, and we'll add that to row 2 to give us our new row 2. And it'll always be the opposite number. If this is a +4, it'll always be a -4. So then, -4 times 1 is -4 plus 4 is 0. -4 times 2/3 is -8/3 minus 1 gives us -11/3. Yeah, -11/3. -4 times 7/3 is -28/3 plus 2, -22/3. Okay, now we work our way down the diagonal. We got a 1 here, zeros below it. So now we want to get a 1 here and zeros below it, but there is nothing below it. So here we can multiply that second row by 3 to get rid of the fraction. So 3 times row 2 will give us our new row 2.
Okay.
So 3 times 0 is 0, 3 times -11/3 is -11, 3 times -22/3 is -22. Then we can divide everything in a row by something. So we can take row 2 divided by -11, and that's going to give us our new row 2. So we got 1, 2/3, 7/3. 0 divided by -11 is 0. -11 divided by -11 is 1. -22 divided by -11 is 2. Now that's a Gaussian elimination. Now Gauss-Jordan says now you go back up the diagonal. You start here and you want to get zeros above it.
Okay.
And then we go here and get zeros above it. And we see if we multiply the 1 here by -2/3, if we add it to 2/3 here, we get a 0. So we'll take -2/3 times row 2 and add it to row 1, and that's going to give us our new row 1.
Okay.
So I got 0, 1, 2. -2/3 times 0 is 0 plus 1 is 1. -2/3 times 1 is -2/3 plus 2/3 is 0. -2/3 times 2 is -4/3 plus 7/3 is 3/3, or just 1. And that was our goal. We wanted to get a diagonal of 1s, zeros everywhere else. That's the full Gaussian and Jordan elimination. And what you do is you put your x, y's, and z's back in, or in this case just x's and y's, and equals. So we got xy equals, xy equals. Now the zeros always drop away, so this first line says 1x or x is equal to 1. This second line, the 0x drops away, we got 1y or y is equal to 2. So our answer would be 1, 2. Now that same principle will hold true if you had a 3 equations, 3 variables, but since we were short on time, I worked a simpler one.
All right. Okay, cool, Professor.
It's kind of the same principle as the other one, except we just don't have all those variables in there.
I see. Oh, it's neat. Oh, thank you for your help, Professor.
You're welcome.
We will see you next week.
Okay. Well, have a great day.
All right. Thanks. You too.